Okay, students, we have found out the value of h of n as 1 by 11, 1 plus 2 cos 2 pi n minus 5 by 11 plus 2 cos 4 pi n minus 5 by 11. Okay. Now we have to calculate the value of h of n for n equal to 0 to 10. Okay. We have to calculate the value of h of n. Calculate the value of h of n for n equal to 0 to 10 by using the symmetric condition h of n equal to h of n minus 1 minus n. Okay, using this symmetric condition and h of n equal to h of n minus 1 minus n with the center of symmetry at n minus 1 by 2. Okay, this will be the center of symmetry. Okay, this will be the center of symmetry. Why we have chosen this expression other than h of n equal to h of minus n minus of h of n? Why? Because the given sample is of odd. Okay, the condition is odd here for the samples, for the number of samples. Okay, therefore the condition we are applying here is h of n equal to h of capital of n minus 1 minus n at center of symmetry at n minus 1 by 2. Okay. Okay, so first of all you have to calculate h of n at n equal to 0 to 5. N equal to 0 to 5. Okay. Okay, then apply first condition when n equal to 0. When n equal to 0, we will get h of 0 as 1 by 11, 1 by 11, 1 plus 2 cos 2 pi 0 minus 5 by 11 plus 2 cos 4 pi 0 minus 5 by 11. Okay, എത്ര കിട്ടും h of 0? We will get h of 0 as 0.0694. Okay, use calculator in radians mode and calculate h of 0. We will get it as 0.0694. Okay, then when n equal to 1, h of 1 will be equal to 1 by 11, 1 by 11, 1 plus 2 cos 2 pi 1 minus 5 by 11 plus 2 cos 4 pi into 1 minus 5 by 11. What will be h of 1? We will get h of 1 as, by calculating this expression, we will get h of 1 as minus 0.054. Okay, similarly n of 2, n equal to 2, h of 2 will be equal to 1 by 11, 1 plus 2 cos 2 pi into 2 minus 5 by 11 plus 2 cos 4 pi 2 minus 5 by 11 എന്ത് കിട്ടും? h of 2 ആയാലും പറഞ്ഞ h of 2 എന്ത് കിട്ടും? ജസ്റ്റ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുന്നേ ഉള്ളൂ ഇവിടെ. h of 2 എന്ത് കിട്ടും? What will be the value of h of 2 here? ആർക്കും കിട്ടിയില്ല h of 2 എന്താന്നുള്ളത്? We are just substituting the values in the h of n expression. Okay, by substituting n equal to What will be the value of h of 2? ആരെല്ലാം പറഞ്ഞേ? Okay, minus 0.1094 minus 0.1094. When n equal to 3, h of 3 will be equal to 1 by 11, 1 plus 2 cos 2 pi 3 minus 5 by 11 plus 2 cos 4 pi 3 minus 5 by 11. എന്ത് കിട്ടും? h of 3. h of 3യുടെ വാല്യൂ എന്തായിരിക്കും പറഞ്ഞ്? What will be the value of h of 3? It is എന്തായിരിക്കും? 0.0474. And similarly for n equal to 4, h of 4 will be 0.3194, and for n equal to 5, h of 5 will be 0.4545. ഓക്കെ, നമുക്ക് എത്ര h of 0 തൊട്ട് h of 5 വരെയുള്ള വാല്യൂസ് നമുക്ക് കിട്ടി. Now applying the symmetric condition. Okay, now we will apply the symmetric condition for obtaining the value of h of 6 to x of 10, h of 10. Okay, therefore when n equal to 6, h of 6 will be h of 11 minus 1 minus 6. Okay, that will be h of 4. Therefore h of 6 will be equal to h of 4. Okay, this will be 0.3194. Okay, this is the condition. Okay, h of n equal to h of n minus 1 minus n is the condition here. Okay, therefore when n equal to 7, h of 7 will be h of 11 minus 1 minus 8, that is h of 3, that is 0.0474. And h of 8 will be h of this is 7, sorry, this is 7. Okay, this is 11 minus 1 minus 8, that is h of 2. Okay, then h of 8 will be equal to h of 2 will be equal to minus 0.1094. Okay, and h of 9 will be equal to h of 11 minus 1 minus 9, which will be equal to h of 1, that will be minus 0.054. Okay, so finally we will also get the value h of 10 will be equal to h of 0, that is 0.0694. Okay, this will be the values of h of 0 till h of 10. Okay, h of 0 till h of 10. Okay, now we will move on to the final step. Okay, we will move on to final step. എന്താണ് final step? You have to find the transfer function h of z. Okay, you have to find the transfer function, that is step 4 will be finding the transfer function h of z equal to summation of n equal to 0 to 10 h of n z raised to minus n. Okay, this will be the equation of transfer function h of z equal to summation of n equal to 0 to 10 h of n z raised to minus n. Okay. Okay. Therefore, h of z can be written as h of 0 z raised to minus 0 plus h of 1 z raised to minus 1 plus h of 2 z raised to minus 2 plus h of 3 z raised to minus 3 plus h of 4 z raised to minus 4 plus h of 5 z raised to minus 5 plus h of 6 z raised to minus 6 plus h of 7 z raised to minus 7 plus h of 8 z raised to minus 8 h of 9 z raised to minus 9 plus h of 10 z raised to minus 10. This will be the expression for h of z. And finally we can convert these values, that is h of by using the symmetric condition. Okay, by using symmetric condition we can write h of n as h of n minus 1 minus n, and from this we can replace h of 0 equal to h of 10, h of 1 equal to h of 9, and h of 2 equal to h of 8, h of 3 equal to h of 8, h of 7, h of 3 equal to h of 7, and finally h of 4 equal to h of 6. Okay, we can replace or we can simplify the expression for transfer function h of z as h of 0 equal to h of 10, h of 1 equal to h of 9, h of 2 equal to h of 8, h of 3 equal to h of 7, and h of 4 equal to h of 6. Okay, then replacing and simplifying h of z, we will obtain h of z as h of z as h of 0 into 1 plus it z raised to minus 10 plus ഇത് റീപ്ലേസ് ചെയ്തിട്ട് ജസ്റ്റ് കോമൺ എടുത്തതന്നേ ഉള്ളൂ. ഓക്കെ, h of 0 into 1 plus z raised to minus 10 plus h of 1 into z raised to minus 1 plus z raised to minus 9 plus h of 2 into z raised to minus 2 plus z raised to minus 8 plus h of 3 into z raised to minus 3 plus z raised to minus 7 plus h of 4 into into z raised to minus 4 plus z raised to minus 6 plus h of 5 z raised to minus 5. ഫൈനലി നമുക്ക് എന്ത് കിട്ടി? ട്രാൻസ്ഫർ ഫംഗ്ഷൻ ഇങ്ങനെ കിട്ടി. ഇനി എന്ത് ചെയ്യണം? വാല്യൂസ് അറിയാലോ, സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തോ വാല്യൂസ്. എന്ത് കിട്ടും? h of z finally we will get h of z as 0.0694 plus z raised to minus 10 minus 0.054 into z raised to minus 1 plus z raised to minus 9 minus 0.1094 into z raised to minus 2 plus z raised to minus 8 plus 0.0474 into z raised to minus 3 plus z raised to minus 7 plus 0.3194 z raised to minus 4 plus z raised to minus 6 plus 0.4545 z raised to minus 5. This will be h of z. Okay. അങ്ങനെ എന്താണ് designing of linear? We have first started with designing of linear FIR filter. So that means we have to find the transfer function of the linear FIR filter. Okay. So finally we found out the transfer function h of z of linear FIR filter by some sort of series of steps. Okay, that is first we have plot the hd of e raised to j omega. That is what? Desired frequency response. അല്ലേ? hd of e raised to j omega. അതിന്ന് എന്ത് കിട്ടി? അതിന്ന് സാമ്പിൾ ചെയ്തു. Sampled and obtained h of k. From this we have found out h of n, and finally we have got the transfer function h of z. Okay, this is the frequency sampling method for designing the linear FIR filter. Okay, we have completed the FIR filter design. Okay, we have completed the FIR filter design. We have seen the two methods by window method and frequency sampling, and we also from window method we have studied three types of window, that is rectangular, Hamming and Hanning. Okay, now we will start with a new topic, that is design of IIR filter. Okay, design of IIR filter. Okay, we will start with a new topic, IIR filter. Okay, the digital filters are divided into FIR and IIR. Okay, this IIR filter is one type of digital filters. Okay, digital filter. What is a digital filter? എന്തായിരിക്കും digital filter? പറഞ്ഞേ, എന്താണ് digital filter? എന്താണ് filter? Filter is used to eliminate or cancel the unwanted components from a response or from a system. Okay, this is the filtering. Okay, and the system implementing this operation, that is the system implementing the filtering operation, is known as filter. Okay, filter. And the discrete time system for the treatment of discrete time signal. Okay, we will process the discrete time signal by using this process of filtering, and for this process we use a digital filter. Okay, digital filter process the digital or discrete time system. Okay, discrete time system. Okay, and this is a basic introduction for digital filter. And again we have seen classical filters. What is classical filter? Classical filter means low pass, high pass, band pass and band stop. Okay, these are the classical filters. Okay, these are the classical filters. Okay, this is a basic introduction. We only need the design of IIR filter rather than studying this introduction. Okay, now you have to write this equation. Please write this equation. FIR filter and IIR filter. Okay, what is the difference between FIR and IIR? Here the impulse response will be finite. Here the impulse response will be finite, and for IIR filter the impulse response will be infinite. Okay, for FIR filter the impulse response will be finite, and for IIR the impulse response will be infinite. Okay, now I have told you, for designing a filter, it means you have to find the expression for transfer function for the given specification. Okay, you have to find the transfer function for the given specification of the filter. For FIR, you have studied the transfer function h of z equal to, right, h of z equal to summation of n equal to 0 to n minus 1 h of n z raised to minus n. Okay, you have already designed FIR filter. There you have used the transfer function expression as h of z equal to summation of n equal to 0 to n minus 1 h of n z raised to minus n. Okay, here, that is, for IIR filter the transfer function can be written as summation of r equal to 0 to m br z raised to minus r divided by 1 plus summation of k equal to 1 equal to n 1 k equal to 1 to n ak z raised to minus k. This will be the transfer function for FIR and IIR filter. Okay, എല്ലാവരും ഇക്വേഷൻ എഴുതിയെടുത്തേ, ട്രാൻസ്ഫർ ഫംഗ്ഷൻ്റെ FIR IIR ഇക്വേഷൻ പെട്ടെന്ന് എഴുതിയെടുത്തേ. ദിസ് ഇസ് വെരി വെരി ഇമ്പോർട്ടൻറ്റ്. ആൻഡ് ഓൾസോ IIR filter can be also known as recursive filter. It can be also known as recursive filter. Okay, എഴുതിയെടുത്തോ എല്ലാവരും? Now you have to study some of the specification of the filter, digital filter. Okay, for that, first you have to plot the magnitude, typical response of the digital filter. Typical response of the digital filter. Okay, omega, this will be gain. Okay, gain g e raised to j omega വരച്ചെടുത്തോ? Okay, this will be the pass band, and this will be the stop band. Stop band. This is the pass band and stop band of the filter, and the space or the area in between the pass band and stop band will be known as transition band. Transition band. Okay, this will be omega p and this will be omega s. This is the transition band. And this will be the 1 plus del p, and this will be 1 minus, sorry, this will be 1 del p, 1 plus del p, and this will be the 1 minus del p. That is, this will be the peak ripple value. This will be the peak ripple value. Okay, this will be the peak ripple value. Okay, and this will be del s. This will be the peak ripple values, and this will be del s. And first, that is 0 to omega p will be pass band, and omega p to omega s will be the transition band, and beyond omega s will be the stop band. Okay, this is the typical magnitude typical magnitude specification for a digital filter. Please note down this figure. Typical magnitude specification for a digital filter. That is, here we are considering low pass filter. Okay, here we are considering low pass filter. Okay, you have to study some more specification, that is a omega, that is loss function. A omega will be the loss function. A omega will be equal to minus 20 log g e raised to j omega in decibel. Okay, in decibel. And also peak pass band ripple alpha p will be equal to minus 20 log of 10 1 minus del p decibel. And minimum, please write these equations correctly. Okay, minimum stop band attenuation. Minimum stop band attenuation will be alpha s equal to minus 20 log 10 del s in decibel. Okay, therefore loss function a omega can be written as minus 20 log 10 g of e raised to j omega decibel, and peak pass band ripple alpha p can be written as alpha p will be equal to minus 20 log 10 1 minus del p decibel, and minimum stop band attenuation alpha s will be equal to minus 20 log 10 del s decibel. Okay, here we have seen the typical magnitude specifications for a digital low pass filter. Okay, for a digital low pass filter. Now, this is a typical magnitude specification. Now you have to normalize this response. Okay, now you have to normalize. Okay, normalize means that maximum value of the magnitude that is gain. Okay, maximum value of magnitude, maximum value of magnitude, that is gain is assumed to be unity. Okay, normalize means that the maximum value of magnitude, that is gain, is assumed to be unity. Okay, unity. Or also you can consider that minimum minimum value of loss function, or minimum value of loss function will be 0 decibel. Okay, you have to normalize this response, that is maximum value of magnitude or gain is assumed to be unity, or the minimum value of loss function is 0 decibels, or the minimum value of loss function is 0 decibel. Okay, now the figure becomes, by normalizing, it becomes figure becomes this will be gain. Okay, gain, this will be gain, and the maximum value is unity. Okay, we will, after normalizing, the maximum value will be unity, and this will be, that is this will be 1 by root of 1 plus epsilon square, 1 by root of 1 plus epsilon square, and this will becomes 1 by a, and this is omega p omega s. Okay, this will be the response after normalizing. Okay, this is also known as transition band. Okay, from this we can write alpha maximum as 20 log 10 1 plus epsilon square decibel. Okay, alpha max, or maximum value of alpha as 20 log 10 1 plus epsilon square decibel. Okay, 1 plus epsilon, so epsilon square decibel, or approximately we can write it as approximately minus 20 log 10 1 minus 2 del p 2 del p decibel. Okay, please write these equations. Okay, okay, എഴുതിയോ എല്ലാവരും ഇത്രയും ഇക്വേഷൻസ്? എഴുതിയോ എല്ലാവരും? ഓക്കെ, ഇനി always while we designing IIR filter, always while we designing a IIR or a digital filter, the first step is that you have to convert digital filter specification into അനലോഗ് ലോ പാസ് പ്രോട്ടോടൈപ്പ് ഫിൽറ്റർ സ്പെസിഫിക്കേഷൻ. ഓക്കെ, എന്ത് ചെയ്യണം, നമ്മൾ ഡിസൈൻ ചെയ്യുന്ന ഡിജിറ്റൽ ഫിൽറ്റർ ആണെങ്കിൽ പോലും നമുക്ക് തന്നേക്കുന്ന ഡിജിറ്റൽ സ്പെസിഫിക്കേഷൻ ആണ്. ഡിജിറ്റൽ ഫിൽറ്റർ ഡിസൈൻ ചെയ്യുമ്പോൾ ഡിജിറ്റൽ സ്പെസിഫിക്കേഷനിൽ ക്വസ്റ്റിനെ തരുന്നത്. ആ ഡിജിറ്റൽ സ്പെസിഫിക്കേഷൻ നമ്മൾ അനലോഗിലോട്ട് കൺവേർട്ട് ചെയ്യണം. അതായത് നമ്മളൊരു അനലോഗ് പ്രോട്ടോടൈപ്പ് ഡിസൈൻ ചെയ്യണം. ഓക്കെ, അനലോഗ് പ്രോട്ടോടൈപ്പ് ഡിസൈൻ ചെയ്യണം. ദാറ്റ് ഈസ്, എഴുതിക്കോ, ഡിജിറ്റൽ ഫിൽറ്റർ സ്പെസിഫിക്കേഷൻസിനെ എന്തിലോട്ടാക്കണം? അനലോഗ് ലോ പാസ് പ്രോട്ടോടൈപ്പ് ഫിൽറ്റർ സ്പെസിഫിക്കേഷനിലോട്ടാക്കണം. നമ്മൾ തന്നേക്കുന്ന ഡിജിറ്റൽ ഫിൽറ്റർ സ്പെസിഫിക്കേഷനെ ഡയറക്റ്റ് ആ സ്പെസിഫിക്കേഷൻ ഇട്ട് ഫിൽറ്റർ ഡിസൈൻ ചെയ്യാണ്ട് പകരം അനലോഗിലോട്ട് കൺവേർട്ട് ചെയ്ത് ചെയ്യുന്നുള്ളതാണ് നമ്മൾ എന്ത് പറയും? ഇൻഡയറക്റ്റ് മെത്തേഡ് ഓഫ് ഫിൽറ്റർ ഡിസൈനിങ് എന്ന് നമ്മൾ ഇതിനെ പറയും. ഓക്കെ, therefore it's also known as indirect filter ഡിസൈനിങ്. ഇൻഡയറക്റ്റ് ഫിൽറ്റർ ഡിസൈനിങ്. FIR ഫിൽറ്റർ ചെയ്തപ്പം അതിനെ നമ്മൾ ഡയറക്റ്റ് എന്നാണ് പറയുന്നത്. ഡയറക്റ്റ് ബിക്കോസ് in FIR we directly design or we directly found the transfer function of linear FIR filter by using the given specification. Okay, here the given specification is again for IIR. Here the given specification is again converted to the analog filter specification. Therefore, this is also known as indirect method of designing. Okay, while FIR is direct method of designing. Okay, now the second step is that to determine the analog low pass filter transfer function meeting the specification. Okay, now we obtained the analog filter specification. Next, you have to determine the analog low pass filter transfer function meeting this specification. Okay, then last you have to transform this obtained analog low pass filter to desired digital filter. Okay, then you have to determine the analog low pass filter to the desired digital filter. Okay, desired digital filter. Okay, next you have to study the filter specification and the problems based on the order of filter. Okay, the problems based on the order of filter. Okay, okay.